Good morning, my dear friends. I hope you all are doing great. So let us start. My dear friends, in previous class we have discussed about RS configuration, which is known as absolute configuration. Okay, what is R? R basically means here rectus, and S stands for sinister. Rectus meaning is basically clockwise, it means clockwise, and sinister means anti-clockwise. In previous class, my dear friends, we have discussed about R and S configuration in one of the amino acids, correct? So let us make few more questions to understand it, okay, as per as examination point of view. Have a look. So let's make one question here. What will be an absolute configuration, okay, of a chiral center in a given molecule? So what will be an absolute configuration, okay, around, we can say around a chiral center, around a chiral center in a given molecule, okay? You can also say what will be the absolute configuration of a chiral center in a given molecule. So a molecule is given to us. Have a look. If we talk about this particular molecule, correct? We have here, let us suppose, we have here COOH, and here we have NH2. Here we have H, and here, let us suppose, we have CH2, then we have SH, correct? Let us suppose this is our amino acid. Everybody knows that this is a cysteine amino acid. So this molecule is given to me. And we know that this is the chiral center of this molecule. So this is our chiral center. So we need to find out the absolute configuration around the chiral center. Okay, or you can say of the chiral center. So last time I told you one important point, that if this is the chiral center here, you have to look into these groups 1, 2, 3 and 4. So have a look at these 3 groups and find out the atomic numbers of those atoms which are directly attached to the chiral center. If you look here, the carbon is directly attached to chiral center. Here hydrogen is directly attached to chiral center. And here nitrogen is directly attached to chiral center, and here the carbon is attached to the chiral center. So my dear friends, if you look at them, you will find out that we have hydrogen in this case, second in case of COOH, and then we have NH2, then we have CH2SH. Okay. In first case, hydrogen is attached and its atomic number is 1. In second case, carbon is attached to the chiral center, its atomic number is 6. In third case, nitrogen is attached to the carbon and its atomic number is 7. And if you look at now the last one, here carbon is attached to the chiral center. Carbon is attached to the chiral center, its atomic number is 6. So if you look here, I told you last time, as far as the periodicity rule is concerned, we have to number these 4 groups, okay, from 1 to 4 on the basis of decreasing atomic numbers. So 4 groups around chiral center are numbered from 1 to 4 on the basis of their decreasing atomic numbers. So if you look here, which one has the highest atomic number? NH2. The nitrogen of NH2 has highest atomic number, that is 7. So that means your NH2 group will come as number 1. It will be numbered as 1. That means it has high purity. So your NH2 group will be considered to be number 1 purity. So I can call it as high purity. Last time I told you it has high purity or the highest purity. After that, we have carbon here, here also carbon we have, correct? So it is 6, it's also 6, and you know that 6 is more than 1. That means 1 is basically the very, very least atomic number here. It is the least atomic number here. 7 is the highest and 1 is the least, correct? So if 1 is the least, I can write down here, my dear friends. So NH2 is having the high purity, it will be considered as number 1. So it's considered as the highest purity group. Highest purity group. If we talk of hydrogen, hydrogen will be considered as 4. So we are doing the numbering from 1 to 4 based on decreasing atomic numbers. When the nitrogen has atomic number of 7, which is high, so it will get first priority. And the hydrogen has the least atomic number. How much is the atomic number of hydrogen? 1. So it will get the number 4. It will be considered as number 4. And number 4 means here the lowest purity. The lowest purity. Correct? So now there remains two groups here. One group is COOH and CH2SH. Now if you compare these two groups, you will find out that carbon's atomic number is 6 and carbon's atomic number is 6. Both are 6. Correct? Then I cannot decide that who is greater. Between carboxylic group and CH2SH group, who has greater purity, I cannot decide on the basis of carbon atoms. Because carbon atomic number 6, atomic number 6, that is same. So I have to go to the first point of difference. This is not the first point of difference, it's first point of similarity. The difference will come now. If you look at oxygen here, in this case, if you look at oxygen, this is your oxygen. And the atomic number of oxygen is how much? 8. So atomic number of oxygen is 8. If you look here, this carbon is linked with sulfur. This carbon is linked to sulfur and this carbon is linked to oxygen. So the carbon which is linked to sulfur, okay, so here it is linked to sulfur. What is the atomic number of sulfur, my dear friends? Atomic number of sulfur is 16. So here atomic number is 16. So who is having more purity now? So on the basis of sulfur, its atomic number has become 60, and on the basis of oxygen, its atomic number has become 8. So now out of them, who is having more purity? So this CH2SH has more purity than COOH. That means after this I will write down here CH2SH. So it will be second purity. And then after that I will write down COOH. COOH. That is carboxylic group, it will be having third purity. So I have given the purities to these groups, okay, on the basis of their decreasing atomic numbers. If you look in the first case, the highest atomic number is for nitrogen, so it will get the first purity. And the least is for hydrogen, so it will get the lowest purity. Look here, the lowest purity it will get, correct? Then I have to decide between carboxylic group and CH2SH group. And carbon is same, atomic number 6, atomic number 6. Second atom I have taken oxygen here, and here I have taken second atom sulfur. Oxygen is just 8 atomic number, sulfur's atomic number is 16. That means more purity will be for CH2SH group now because atomic number is more. So it will come to the second place, and then carboxylic group will come to the third place, and finally we have already hydrogen here. So this is the purity order, correct? So this is the periodicity order. So I hope that you have understood the order of periodicity. After understanding it, let us understand what will be the absolute configuration around a chiral center. This chiral center. So what is the absolute configuration around the chiral center in this molecule? We have to find out. Okay? I hope you are ready. So I will take it down. So let us take this molecule here, my dear friends. This is the chiral center here. And here we have COOH. Here we have H. Here we have NH2. Here we have CH2SH. If you remember now, this group is getting the first priority. First, basically here means it has high atomic number, the highest atomic number. So, first priority. Then between COOH and CH2SH, this group is getting second priority. And this group is getting third priority, and this one is the fourth. Correct? So, this is our hydrogen, which is fourth. And you know that hydrogen is basically the lowest purity group. Correct? So I told you last time, if you remember, the lowest purity group is hydrogen. And this hydrogen is present on which line? Vertical line. So I will write down the lowest purity group, which is hydrogen, is present. You can also say in place of group, you can say atom also. Lowest purity group, or you can say atom. Present on vertical line. Or I will write down when the lowest purity group is present on vertical line, then R means rectus configuration, clockwise rectus configuration. R is taken as R and sinister is taken as sinister. That means S will be taken as S and R will be taken as R. So let's understand. So my dear friends, the hydrogen is basically your lowest purity group. So when lowest purity group is present on the vertical line, then if you get the R configuration here, it will be taken as R only. And if you get S configuration, it will be taken as S. This is just a trick to remember the things. So have a look. We know that we have to move from 1 to 3. We have to move from 1 to 3 to find out the absolute configuration. Correct? So let us move from 1 to 3 to find out absolute configuration. So have a look. This is our 1, this is 2 and this is 3. So our movement should be from 1 to 3. So this is our movement, so from 1 to 3. If you look at 1 to 3, you are basically moving like this. And this movement is basically anti-clockwise movement. And what is anti-clockwise, my dear friends? Sinister. Sinister means S. So that means this is anti-clockwise. You are moving anti-clockwise. And meaning of anti-clockwise is here S. So my dear friends, if you get R, R will be taken as R only. And if you get sinister configuration, it will be considered as sinister only. When your lowest purity group or atom is present on vertical line. Look here, hydrogen is present on vertical line here. So which configuration you are getting? S configuration. And S is taken as S. So you should not change it, you should keep it as S only. So this is a trick actually. So you are getting here S configuration. My dear friends. So, my dear friends, this particular carbon, because of this rotation, okay, from 1 to 3, this rotation was anti-clockwise rotation. And because of that anti-clockwise rotation, we are using term S. So, the absolute configuration of this chiral carbon is S. So, this chiral carbon will have absolute configuration of S in this particular amino acid, which is cysteine. So my dear friends, this carbon will have S configuration. And this S configuration is decided on the basis of groups which are around a chiral center. So these groups are around the chiral center. So based on these groups, I am deciding what will be the absolute configuration of chiral carbon. So answer is S configuration. So this carbon will have S configuration, my dear friends. I hope you are understanding. Everybody has understood this thing? Now there's a question. What kind of S it is? Is it 1S? Is it 2S? Is it 3S? Is it 4S? We have to decide that thing as well. So in order to decide that, have a look. I will draw this molecule here. Okay, COOH. Then we have NH2 group. Then we have hydrogen. And then we have CH2SH. Okay. If we talk about nomenclature, numbering, I am not talking about the numbering on the basis of purity rule. I am talking the numbering on the basis of nomenclature. You know that carboxylic group is a strong functional group. So numbering will be done from carboxylic group only. So 1, it will become 2, and this will become 3. So my dear friends, this chiral carbon is basically the second carbon. This chiral carbon is a second carbon when you are doing the numbering in terms of nomenclature, right? For the sake of naming this molecule, you are doing the numbering now. So this numbering has nothing to do with the atomic numbers. It is just for the nomenclature. So if you look at this carbon become a second carbon. So your chiral carbon become a second carbon. And we know the configuration of this second carbon, which is chiral carbon. It is S configuration. And this second carbon is basically a chiral carbon. So we'll call it as 2S configuration. Because we know that our second carbon is a chiral carbon, so it will become 2S, my dear friends. So dear friends, let's talk about what will be the absolute configuration, my dear friends. The absolute configuration means RS configuration. Around 4 chiral centers in D-glucose molecule. I have drawn this molecule many a times. Let's have a look. So if we draw this structure here, please have a look. This is our glucose molecule, my dear friends, D-glucose. Third, fourth, fifth, and sixth one. CH2, OH, 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 and third carbon has OH group on the left side. Let us do the numbering based on the nomenclature, my dear friends. We know that already that there are 4 chiral carbons in it. And we have to find out RS configuration around these 4 chiral centers. Let us see the numbering first of all. 1, 2, 3, 4, 5, and 6. Correct? So second carbon is chiral, third carbon is chiral, fourth one is chiral, and fifth one is chiral. So we have to find out the absolute configuration around this chiral center, this, and this. 4 chiral centers. So you remember this nomenclature, it is basically the numbering which starts from functional group here. So it is useful in the nomenclature of this particular compound. Okay, you remember this numbering. So this is our D-glucose. What is my first point is that I will take this carbon number second actually. Okay, you can also look here 2, 3, 4, 5. That means you are supposed to find out absolute configuration around second carbon, third carbon, fourth carbon, fifth carbon, which are chiral carbons. Correct? So let us start. Let us take the first chiral carbon, which is second carbon here. So how can I write it down? Have a look. C double bond O H. That is our first carbon. Let me write down the second one. Second one is here. C OH H. Then the third carbon will have C H OH and the rest of the molecule. Correct? I am only talking about here which carbon? Second carbon. This is first carbon, this is second carbon, this is third, but I am talking only about second carbon here. So remember, this is our second carbon, which is a chiral carbon. This carbon I am talking about. Correct? So have a look. First of all, I have to find out the purities, like from 1 to 4. From highest atomic number to the lowest atomic number I have to go. That will be from 1 to 4. If you see this carbon here, it is attached to oxygen. Here it's attached to carbon. Here it's also attached to carbon. Here it's attached to hydrogen. Correct? So my dear friends, how many atoms are directly attached to this chiral carbon? Can you tell me? How many atoms? Like this carbon, oxygen, carbon and hydrogen, they are attached. What is the atomic number of this oxygen? It is 8. What is the atomic number of this carbon? It is 6. Atomic number of hydrogen is 1. And atomic number of this carbon is also 6. So my dear friends, the highest atomic number is for OH. Okay, so this will get the first purity, that's 1. And the least is for hydrogen. This will get the purity number 4. Highest atomic number will get the purity of 1 and the lowest atomic number will get the purity of 4. Now I have to decide between this group and this group what will be the purities. I have to decide. So here we have 6, here also 6. So cut it down. So let's cut it down because atomic numbers are same. So then I have to make a first point of difference. This is similarity. 6 and 6 is similarity. So first point of difference I have to see. Remember always, here we have oxygen. Here also we have oxygen, my dear friends. Here we have oxygen and here also we have oxygen. So what is actually the highest purity then? Atomic number is 8. Here also atomic number is 8. Correct? So what should I do now? Remember always, here you have C double bond O and here you have C single bond O. And remember, C double bond O will get more purity than C single bond O. So which one will get more purity? Here I am not talking about phantom atoms. I am not opening up this molecule. Directly you can remember, C double bond O will have more purity than C single bond O. Correct? So double bond will have more purity than single bond. So double bond will have more purity than single bond. Correct? Here we have a carbon single bond oxygen and here we have a carbon double bond oxygen. That means this will get more purity than this. So on the basis of this I can decide now, okay, that what will be the purity, numbering, like from 1 to 4. 1 is for the highest and that highest is here which group? OH. So it will get our number 1. And this is the least atomic number, so it will get number 4. So this is highest purity, remember HP, and this is the lowest purity, remember LP. Highest purity, lowest purity. And now if we talk about this group CHO and this group C double bond O will get more purity as compared to C single bond O. So now CO will get more purity than C single bond O. So this is more purity, so it will become 3 automatic, it will become 2 because we have written this as 1 and this is as 4. So 2 are remaining there, 2 and 3 numbers. So this will become 2 now and this guy will become 3. That means now we have decided OH group is 1 and H group is 4. But between C double bond O and C single bond O, C double bond O will have more purity. Because of that more purity, okay, it will get number 2 and it will get number 3. Why it's getting 2 and 3? Because already 1 is for OH group. Correct? So let us decide now here. My dear friends, let's write down it in a proper way now and see what will be the rotation. So we have here now CHO, this is aldehyde, CHO. Now we have here OH and H, and finally we have here CHOH, CHOH, and then the rest of the molecule is also there, correct? Rest of the molecule will be here like 1, 2, 3, 4, 5 and the 6th one. So let's decide up to here only. So this will be your number 1 now, this is your number 4, this is your number 2 and this is your number 3. Correct? So these numbers I can write down here also. So rotation should be from 1 to 3. You have to understand that this 4th does not exist. This is the lowest purity. So this is our lowest purity and this is the highest priority. So rotation should be from 1 to 3. So my dear friends, I will write down this 1 here, okay, this 2 here, and this 3 here, and this is the 4th, leave it. So rotation has to be from 1 to 3. So this is the rotation. Actually you are moving from 1, 2 to 4, but you have to imagine that 4 does not exist. Imagine that there is nothing like 4. You imagine that you are moving from 1 to 3, because 4 is the lowest priority. You think that this group is not existing here because it will be out of plane actually. So now if you see this arrow, you will find out that this is anti-clockwise movement. See this arrow. This arrow gives me anti-clockwise movement. Correct? Anti-clockwise. Correct? Anti-clockwise basically means S. So the configuration has to be S. So S configuration. But there is a point. What is the point I want to tell you? That this lowest priority, if you look at the lowest priority, this is 4th priority, H. Okay. I have told you last time about the lowest priority, if you remember. If you have remembered that particular thing, I have already told you. When lowest priority is on horizontal line, look at this line, this is horizontal line. When LP means lowest priority is on horizontal line, then R is taken as S and S is taken as R. So my dear friends, if you get R configuration, it will be taken as S, and if you get S configuration, it will be considered as R. Correct? This is actually a trick. You can rotate the molecule also and you can easily find it out whether this is true or not. But we don't have that much of time, so what we are going to do is, we will remember this trick actually. This is the trick. When lowest priority is on horizontal line, look here, this is lowest priority, it's on horizontal line, then R is taken as S and S is taken as R. What is the configuration I got? I got S configuration, and we know that the lowest priority is on which line? Horizontal line. Then this will be cancelled and the actual configuration will be basically like this, clockwise, and you can consider it as now R configuration, my dear friends. And we know, if you look at the glucose molecule, this is the second carbon. We were finding out the absolute configuration around second carbon. If you look here, this is the second carbon here, second chiral carbon. So this will be considered as here 2R, and it was considered as 2S. So my dear friends, the configuration will be 2R. So if you look here, here we have 2R, here we have 2R, and here, okay, two places we have 2R. So answer can be either A or it can be C. B and D will not be your answers. So my dear friends, your answer can be either this option, or it can be the first option, or it can be the C option. But let us decide it. Because if you look at here, it is 3S. Here it is 3R. So this second point of configuration will decide whether your answer will be A option or C option. Second point will decide. So I hope you have understood, my dear friends. So 2R is the configuration there. Let us go to now chiral carbon third here. Okay? That is the second chiral carbon, but the number is third. Dear friends, let's take the second chiral carbon, but the number of that second chiral carbon is 3. Okay? Because it's the third carbon in the molecule, but it's the second chiral carbon. So I will write it like this: C double bond OH, then I will write down CHOH. Okay? After that, I will write down the third carbon, which is also the chiral carbon here. And then finally, you will be having CHOH 2 times, then CH2OH. This is our molecule. So my dear friends, we know that atomic number of oxygen is 8. So it will be the first priority. So I will call it as number 1. So it's called as the highest priority, HP, highest priority. And we know that the atomic number of hydrogen is 1. So this is the very less atomic number, least atomic number. So it will be the lowest purity. So hydrogen will be the lowest purity, correct? And lowest purity is nothing but it is 4, considered as 4. Lowest purity. After that, now we have to decide on the basis of like which one will be the second and third purities we have to decide. If you look up, there is CHOH. Here is also CHOH. Same. Here is CHOH. Here is also CHOH. So I can't decide. Atomic numbers will be same. But look here. Here you will have C double bond O. Correct? But in this particular case, if you open up, here you will be having C single bond O. Let me open it up basically. Let me make it like this. CHOH, then CH2OH. Here the atomic number of this group and this group will be same, so no difference. But if you go up, here we have C double bond O and here we have C single bond O. That means this C double bond O will have greater purity than C single bond O, correct? So this will be the highest and this will be lowest. So this will get high purity, this will get low purity. But we have already written first purity and fourth purity, we have already written. Now we are having two more purities like 2 and 3. 2 will be highest and 3 will be the lowest. Correct? So my dear friends, which one will get the higher purity? This upper group will get the high purity and this will get the low purity. And here the high purity we have is 2 and this will get low purity which is 3. So here we are getting 2 and here we are getting 3. Correct? So between these two groups, now this group and this group, this upper one is 2, lower one is 3. So when we know that upper one is 2 and lower one is 3, let us make a movement. From 1 to 3 we will make a movement here. So 1 to 3 means from here, this is 1, this is 2 and this is 3 and this is the lowest purity here. So my dear friends, we have here CHOH, then you have CHO, here you have now CHOH whole twice directly, then CH2OH. Now this is the chiral carbon, which is third carbon actually. Here we have H, here we have OH. This is first purity, this is second purity, this is the fourth purity, keep it out, and this is the third purity. So movement has to be from 1, 2 and 3. So move like this, 1, 2 and 3. Correct? So when you are moving from 1 to 3, you have to imagine that fourth purity is not there. This is highest purity and this guy is the lowest purity. Remember that. So after that the movement is like this. That means the arrow has to be clockwise. And this is clockwise rotation. Clockwise rotation. Clockwise basically means here R. So we'll get R configuration. And we know that we are finding out the configuration of which carbon? It is the third carbon we are finding out. So it will become 3R because it's our third carbon in this molecule. So 3R it will become. But we also told you that if the lowest purity, look here, the lowest purity. So this is lowest purity hydrogen. It's on which line? Horizontal line. So lowest purity on horizontal line. Just now I told you. When lowest purity is on horizontal line, R changes to S, okay, and S changes to R. S changes to R. Now my dear friends, if you have R, it will become S. If you have S, it will become R. What do you have? You have R, and the lowest purity is hydrogen here. It's on horizontal line. When something is on horizontal line, something means here lowest purity is on horizontal line, then R will become S, S will become R. So you got R, so R will become S. So it will become anti-clockwise like this. So you have here anti-clockwise and actual. So actual is anti-clockwise. That will become 3S configuration. So my dear friends, it's now clear that my answer will be, it's 2R here also 2R. It is 3S and here it is 3R. But 3S is the correct one. Okay? So my answer will be now, without any doubt, it has to be the first option only. But we can also find out that in terms of, now I will take now fourth carbon here, my dear friends. Let me take on the fourth carbon. So let us decide on the basis of fourth carbon now. So if I take the fourth carbon, here is OH and here is H. Then we have third carbon and second carbon. We can write down them like CHOH whole twice. Then C double bond O and H. This is first carbon, second, third and fourth carbon. This is our fourth carbon. Correct? It's a chiral carbon. Then fifth carbon is there, CHOH. Then finally we have here CH2OH. Correct? Now my dear friends, this is our fourth carbon. We are supposed to find out its absolute configuration. Oxygen is basically 8, so it will get number 1. That is the highest purity. Hydrogen is basically, you know what, atomic number is 1, so it will get 4 as the lowest purity. 4 stands for here lowest purity, number 4. So highest atomic number means number 1, that is highest purity. Lowest atomic number means low purity or lowest purity, that is number 4. Now 2 and 3 we have to decide. We know that here we have CHOH, here also we have CHOH. Correct? But here we will be having, look here we will be having COH, that is C single bond O, C single bond O. And here we have C double bond O. We know that C double bond O has more purity than C single bond O. That means I will take this upper group only in consideration. So this will become 2 and this down group will become 3. So we have decided the numbering now here, my dear friends. So we can easily do it now. Have a look now. C, just a minute. OH, H, CH, OH, 2 times C double bond O and H. Then we have here CH, OH, then CH2, OH. So my dear friends, this is our number 1, this is our number 2, this is our number 3 and this is our number 4. This is our highest purity, correct? And this is our lowest purity, correct? So we have to move from 1 to 3. So 1, 2, 3 we are moving like this. Think that this does not exist. So you are moving from 1, 2 to 3. You think that 4th is not there. Understand like this. So 1 to 3 when you are moving actually anti-clockwise. That is anti-clockwise. Anti-clockwise basically means S configuration. Correct? But you know that the lowest purity, look here, lowest purity is on horizontal line. When lowest purity is on horizontal line, then what happens? R changes to S and S changes to R. So what is my configuration? S, and we know that we are talking about which carbon here? Fourth carbon, fourth chiral carbon. That means this carbon is basically the fourth carbon actually in that structure. So it will become 4S. But we know that when lowest purity is on horizontal line like this, R changes to S and S changes to R. What we got here? S. So S will change to R actually. So you will get here 4R configuration. Because lowest purity is on horizontal line. So you will be getting here 4R configuration. So let us talk about now last chiral carbon, which is the fifth chiral carbon here, and decide what kind of absolute configuration it will have. So we have here C double bond O single bond H, then we have CH, OH, 3 and 1, 4, then fifth one will be here C, H, OH, and the last one is CH2, OH. So obviously this OH, oxygen has the highest atomic number 8, so it will get first purity, that is the highest purity it will get. And this one is atomic number is 1 only, it will get the lowest purity, okay, and that lowest purity is the purity 4, correct. Now 2 and 3 we have to decide. Obviously here we have a C double bond O and here we have C single bond O actually. So this will get the second priority, this will get the third priority. So let us move. Okay, CH, OH 3 times, then CHO aldehyde, then CH2OH, then we have here OH and here we have H. This is our lowest priority, number 4. Okay, your movement should be from 1, 2 to 3. So movement should be 1, 2, 3 like this. And 1, 2, 3 movement is basically here S configuration. Anti-clockwise, it's anti-clockwise, so S configuration. And you know we are discussing now about 5th carbon. So 5th carbon basically means the last chiral carbon here. So this is 5th carbon. This is the last chiral carbon of glucose. So it will become 5S. But we know that the lowest priority group, that is hydrogen group or atom, is on horizontal line. Look at this on horizontal line. So what will happen? R will change to S and S change to R. Correct? So my dear friends, this is on horizontal line, lowest priority, so it will change to R configuration, which are 5R configuration, because it's the 5th carbon in glucose. Why 5R? Because 5th carbon in glucose. So 5R will be the configuration right out here. So all 4 chiral carbons of glucose, if you look, the first one will have, the first chiral carbon is basically the second chiral carbon. Its configuration is 2R. So second carbon's configuration is basically 2R. Third chiral carbon has a configuration of 3S. Fourth will have a configuration of 4R. And the 5th carbon, chiral carbon, will have a configuration of 5R. So these are basically the configurations of, absolute configurations of 4 chiral carbons in glucose molecule. I hope you have understood this explanation and all. Okay, please make note of it. So dear friends, let's take 1 or 2 more examples to discuss RS configuration. It's a very important question as far as competitive exams are being concerned. So let's take 2 more examples here. Have a look. If you have a molecule like this, C double bond O, OH, carboxyl group on one side, then you have, let us suppose, SH here, then you have Cl here, and then you have, let us suppose, okay, OH group. So this is your molecule. And you know that this is your chiral carbon. And remember, the numbering will always happen from carboxyl group. So numbering will be 1 and 2. So this will be your second carbon. So this chiral carbon will be your second carbon. You should decide that first. If you do the numbering of that, this COH, COH will be here, SH is here, and Cl is here. This numbering is 1 and 2. So that means your second carbon is chiral carbon. So this is your chiral carbon. Remember that. So let us find out RS in this particular structure. So my dear friends, we know that we have here carbon, here atomic number is 6. Here we have oxygen, here atomic number is 8. Here we have chlorine, here the atomic number is 17. Here we have sulfur, the atomic number is 16. For sulfur, for chlorine, which are directly attached, for oxygen and for carbon. We know the highest atomic number is for, chlorine. So chlorine will get the highest priority. So HP. Highest priority is nothing but it will get the priority number 1. And that 1 is nothing but, my dear friends, it is the highest priority. So it will be your highest priority group. So that means your chlorine will get number 1. After that, sulfur has atomic number of 16. So it will get the second priority. Okay. Then after that you have oxygen, atomic number 8. So its priority will be 3. And then C of carboxyl group, atomic number is 6. So least atomic number is here, that is 6. So it will get number 4. And everybody knows that number 1, chlorine will be number 1 priority. There is the highest priority. and number 4 basically means atomic number is very less. So that means it will get the lowest priority. So this is basically the lowest priority group. And here we have highest priority group. Clear? Now let us decide, okay, what will be the configuration of this molecule. So let us understand. One side we have SH, then we have COOH, then we have OH, and then we have Cl. And we know that Cl is the highest, so 1, this guy is 2, and this guy is 3, and this guy is 4. So forget about it. This is the lowest priority, it's 4. We have to move from 1 to 3. So let's move from 1 to 3. So when you move from 1 to 3, have a look. This is clockwise. So you are getting here R configuration. R configuration basically means it's a clockwise configuration. Correct? And we know that this carbon, which is a chiral carbon here, it is which carbon? Can you look? Is it first carbon or second carbon? Carboxylic group is first carbon, functional group, and this chiral carbon is basically the second carbon. So my dear friends, when this is second carbon, understand that this chiral carbon is basically your second carbon in numbering, so you will get 2R. If chiral carbon is third carbon, you will get 3R. If chiral carbon is 8th carbon, you will get 8R. But you know that fourth group is nothing but it's the lowest priority. Lowest priority is on, look here, COOH is basically fourth lowest priority. Lowest priority is on which line? Look here, this is horizontal line, is on horizontal line. When the lowest priority is on horizontal line, R changes to S and S changes to R. That means what we got? We got 2R. So neglect it and change it because your lowest priority 4 is on horizontal line. Correct? So my dear friends, my actual configuration will be like this now. It was 2R, but I have changed to clockwise to anti-clockwise. I have to change. And 2R will become 2S configuration. So my dear friends, this carbon here will have an actual 2S configuration, absolute configuration. Because when lowest priority is on horizontal line, understand that the configuration will become exactly opposite. If you are getting R configuration, it will not be the answer. You have to change R to S. S will be the answer for that. That's a trick. Dear friends, I hope you have enjoyed today's session, and you can also find out RS configurations in fructose, in mannose, in ribose, all these sugars. You can try at your own place the RS configurations in different sugar molecules, and even you can try it in amino acids also, whether it will be R or S configuration. Remember, whenever you are getting an S configuration for any chiral center in a molecule, what happens? You should look the lowest priority. Lowest priority basically means priority number 4. That 4 is nothing but actually that group which has the least atomic number. Okay, that is called as lowest priority, and it will be given number 4. If that lowest priority group, it can be any group, it can be hydrogen or any other group, and if it is getting the lowest priority 4 and it is present on the horizontal line, okay, then if you are getting R configuration, it will be changed to S configuration. If you get S configuration, then it will be changed to R configuration. But if your lowest priority here basically means on the base of atomic number, decreasing atomic number. Highest priority group is highest atomic number, that is 1. Lowest priority means lowest atomic number, that is 4. So if your lowest atomic number group, that is the lowest priority group, is present on the vertical line in a molecule, then if you get R configuration while moving from 1 to 3, if you get R configuration, okay, then what happens? In that R configuration will be taken as R only, no need to change now. But when your last fourth group, that is lowest priority group, is present on vertical line, R configuration will be taken as R only, and S configuration will remain S configuration only. Please keep that thing in your mind, and you can do for other molecules as well. You can do it for amino acids, you can do it for carbohydrates, and it's a very important question for your competitive exams. Please take care of yourself. Have a good time. Thank you.